All right, here we are talking about the characteristics of stars. And first, let's kind of define what a star is. So, a star is a large ball of hot gas that emits a huge amount of energy. Okay? Different types of gases, mainly hydrogen and helium, but there can be all kinds of different elements in a star. Essentially, it's a huge ball of hot gas. The closest star to Earth is, of course, the Sun. And the distance between the Earth and the Sun is a very special basis of measurement for our solar system. It's called an astronomical unit. And that's abbreviated to an AU, A.U. And an astronomical unit is 149.6 million kilometers. So almost 150 million kilometers. That's a really, really far distance. In our solar system, it's actually kind of right next door. And in terms of the universe, it's really, really close. But for a human, that's a huge distance. Okay. Other stars, however, are really, really, really far away. Okay, so we measure the distance to those stars, not to our sun, but to those stars in light years. A light year is the distance light travels in a year. So it's a distance, and because light travels really fast, right? Light travels at 300,000 kilometers per second. In 1 year, that means that it travels 9.5 trillion kilometers. Which is an unfathomable number. But that's how we measure the distance to other stars, because they're really far, right? So we measure it in light years. The colors of stars also tell us something about their temperature. So a relatively cool star glows red, and a very, very hot star glows blue, which is a little bit counterintuitive. But this has to do with the electromagnetic spectrum. And it has to do with, when we look at the light that's coming from stars, to us, they all just look like twinkling little bits of white light in the sky to the naked eye. But of course, when you look at light through special instruments, you see that light, some of it is a little bit red, some of it is, and then other stars that are hotter are a little bit blue. Okay. Stars can range in size from being very small. Small stars they're called dwarf stars, and very large stars are called supergiants. Okay. We can also classify stars by their brightness. So there's temperature, there's size, and then there's brightness. Okay. The apparent magnitude of a star refers to the brightness of the star as it appears to us from Earth. So we know that there's a couple of stars that are up in the night sky that are really, really bright. And we would measure that as an apparent magnitude, right? However, that's not always the best indication of how bright the star actually is, because stars that are a little bit closer will actually appear to be much brighter than a star that's further but actually is a lot brighter, right? Because brightness has to do with, the amount of light that's flowing out of that star. And so we have another measure called the absolute magnitude. And this refers to the actual amount of light that a star gives off from a standard different distance. So a very, very, very bright star that's much farther away is going to appear to us to be more dim. And so if we want to talk about the actual amount of light that stars are giving off, then we need to use absolute magnitude rather than apparent magnitude. Let's talk briefly about constellations. Constellations are a group of stars that form a pattern in the night sky. Many constellations represent characters from Greek or Roman mythology. They also represent sometimes common animals or common objects. And during nighttime, constellations, just like the sun does during the day, at night, constellations will rise in the east and they will set in the west, and that's due to Earth's rotation about its axis. During the year, some constellations can only be seen during certain seasons, and that's because of the sun blocking our view of stars. Because those stars are still there during the day. Like there's still stars that are up in the sky when we look out. It's just that the sun, because it's up during the day, blocks our view because the sun is so much brighter. As the Earth revolves around the sun, this trip takes 1 year, new stars become visible, and then others get hidden by the sun during the day. So that's why some of our constellations are summer constellations like Leo. Some of our constellations are winter constellations like Orion. And some stars that are directly overhead can be seen during all seasons. So that's why in North America, the Big Dipper, the Little Dipper, and Cassiopeia, these are three that are up in the northern sky. They're really right above us, like if we look up. And so they're never blocked by the sun. And so they're three of the most common constellations that we can see in the Canadian sky all year. The Big Dipper is usually easy to find, right? So it's usually right overhead. And then you can use some of these guides to help you find the others, right? So the Big Dipper is usually easy to find. It's directly overhead and its stars are very bright. And once you find it, you can usually find the Little Dipper as follows. So here I'll kind of draw it on this diagram. You basically use the two stars that are the farthest from the handle, and they point to the North Star. Okay, so if we were to diagram this out, these two stars point to the North Star, and that helps you find the Little Dipper. And once you can find the Little Dipper, once you found this star, you can find the rest of the Little Dipper. And then Cassiopeia is really easy to find just on its own. Cassiopeia tends to be a star that kind of is shaped like a W. And you can see it here in this diagram. And it tends to be one that's somewhat easy to find. So what we're going to do for the rest of this activity is this kind of, it's a star map activity where I've given you these star finder pages, and you can cut out and then answer these questions.